Ever tried having a video call with someone who speaks a different language? You know, the kind where you're both waiting for subtitles or awkward pauses. Well, imagine if that translation happened as they spoke. No delays, no jargon. That's the magic of simultaneous speech translation, or SimulST. But here's the thing, it's a high-stakes game. Translate too fast and you'll get confused. Translate too slow, and the conversation falls apart. Today we're diving into how a new AI called REINA is cracking this code, using math, not just magic. Let's start with a problem. Traditional translation models work like this. They wait for the whole sentence, then translate. It's like listening to a whole song before figuring out the lyrics. But in real life, we need instant responses. That's where SimulST steps in, translating as the speech happens. But here's the catch. How do you know when to stop listening and start translating? Most models use rigid rules, like waiting for a set number of words. But languages aren't all the same. German sentences can be longer, Spanish flows differently, and French has those tricky accents. Fixed rules. They're like trying to fit a square peg in a round hole. Previous methods either messed up translations or struggled to train properly. Enter REINA, short for regularized entropy information-based loss. This isn't your average AI. It's like a detective that decides, do I have enough clues to solve this mystery or should I keep listening? How? It uses a concept called information theory, the same math that powers your GPS and streaming services. Here's the trick. REINA calculates the entropy of the audio, which is basically a measure of uncertainty. If waiting for more words reduces that uncertainty a lot, it keeps listening. If not, it translates. It's like asking, is this sentence going to make sense if I wait a second, or should I jump in now? But how does it actually work? Let's break it down. REINA has two parts, an acoustic encoder that turns sound into data, and a text decoder that turns that data into words. But here's the twist. It also has a policy network, a tiny AI that acts like a traffic cop, deciding when to read, listen, and when to write, translate. The magic happens during training. REINA doesn't just learn to translate, it learns when to stop listening. It uses a special loss function that encourages the policy to be monotonic, meaning it doesn't flip-flop between listening and translating. This ensures the model doesn't backtrack, which would cause delays. Now let's talk numbers. Researchers tested REINA against other systems like Seamless, EMMA method. While EMMA delivers strong results, it's computationally expensive to train. REINA, on the other hand, achieves comparable performance with a fraction of the cost. Think of it like building a house. EMMA is the luxury mansion that takes years and a fortune to construct, while REINA is the sturdy, efficient shed that gets the job done without breaking the bank. But how do we measure success? Metrics like BLEU scores, which evaluate translation quality, and average lagging, which tracks processing delays, tell the story. In tests, REINA matched Seamless on French to English and Spanish to English translations, but with significantly lower training costs. The dotted lines in the graphs represent non-streaming translations, like waiting for the whole speech to finish. The goal is to get as close to that quality as possible while keeping lag low. Here's the twist. Even with these advances, challenges remain. When researchers tested REINA against industry leaders, they hit a snag. Audio trimming, using tools to cut out silence, actually messed with the results. Why? REINA was trained on untrimmed audio, expecting some silence at the end. When that silence got cut, the model kept talking, adding extra words it shouldn't have. It's like a chef who's used to cooking with a specific ingredient, suddenly facing a recipe with missing spices. The result? A dish that's a little off. This research isn't just about better scores, it's about building systems that work in the real world. Whether it's a conference interpreter or a live captioning app, the goal is to make AI translation fast, accurate, and reliable. And while we've made progress, there's still a long way to go. So next time you see a live translation, remember, it's the result of countless trials, some dead ends, and a whole lot of math. Thanks for watching, stay curious, and let's keep pushing the boundaries of what AI can do.